Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 14.1, Problem 4. This is Section 14.1, Problem number 4. It says, consider the function f of x equals 4x cubed plus 6x squared minus 24x plus 11. Find the absolute maximum and absolute minimum on the interval 0, 2. So from 0 to 2. Now if you notice, this is the same problem as problem number 3, except the interval is different. Now that's going to change the answer. So it's the same 6-step process. Step 1 is find the derivative. So f prime of x equals, so the 4x cubed will give me 12x to the second. And again, that comes from the exponent of 3 coming down times the number in front of 4. 3 times 4 is 12. And the exponent is reduced from third power down to second power. Then the next piece, 6x squared, has a derivative of 12x to the first power. And again, that comes from the exponent of 2 coming down times the number in front of 6. 2 times 6 is 12. X, 1 less power, second power goes down to a first power. Then minus 24x. The minus 24x has a derivative of minus 24. And again, when you have something with an x to the first power, the answer is whatever number is in front of the x. And the plus 11 at the end, it has no x, so its derivative is 0. So that's the answer to step 1. F prime of x is 12x squared plus 12x to the first minus 24. Step 2 is set that answer equal to 0. So 12x squared plus 12x to the first minus 24 equals 0. Now a problem like this with an exponent other than first power, you have to solve by factoring. So I'll start by pulling a 12 out of every piece of my equation here. So I'm going to write a 12 in front of a set of parentheses. It's still equal to 0. So in the parentheses I'll have an x squared, an x to the first, and a minus 2. So you can confirm that 12 times x squared would be 12x squared. 12 times x to the first would be 12x to the first. And 12 times minus 2 is minus 24. Again, careful with the sign. And now what I have in the big set of parentheses can be broken into 2 smaller parentheses by factoring. So I'm going to do x, x. And I want 2 numbers to multiply to be minus 2 and add to be plus 1. And those numbers would be positive 2 and minus 1. And you can confirm that if you do out the FOIL, combine your like terms, you will get the values in the line above. So to solve for x now, each factor, a set of parentheses, will give me a solution. 2 factors, 2 solutions. The factor of x plus 2 gives me a solution of x equals negative 2. Again, if I put in a negative 2 where I have an x, it will make the equation true. I'll get 0 equals 0. And the other factor, x minus 1, will give me a solution of x equals positive 1. Again, if I put in an x of positive 1, I'll get 0 equals 0. The 12 in front doesn't give me an answer because it has no x with it. Where I have an x, I get an answer. So now I have 2 solutions. That's step 3, solve for x. I found 2 solutions for x. Step 4 is put any solutions from step 3 that are within the given interval into f of x to find the height. Now notice x equals negative 2 is not within my interval that goes from 0 to positive 2. Negative 2 is outside of that interval. At this point I'm done with x equals negative 2. I don't even consider that anymore. X equals positive 1 is within the given interval from 0 to 2. So I do have to find the height for x equals positive 1. So let me put positive 1 into my function, find f of positive 1. So f of 1 equals 4x cubed becomes 4 times 1 cubed. Plus 6x squared becomes plus 6 times 1 squared. Then minus 24x will be minus 24 times 1. And I have a plus 11. And if you do the math, 4 times 1 cubed, do the 1 cubed first, you can get 1. And then times the 4 in front, 1 times 4 is 4. The next piece, 6 times 1 squared, do the 1 squared first, you get 1 times the 6 in front, 1 times 6 is 6. And then 24 times 1 is 24. Pay attention to the sign, it's going to be minus 24 because negative 24 times positive 1. And you have an 11 at the end. Now I have positive values of 4, 6, and 11. If I add those up, 4 and 6 is 10, 10 and 11 is 21. So now I have a positive 21 and negative 24. Positive 21 and negative 24 is minus 3. So there's one height. Now the next step, I have to find the height of either endpoint of the given interval. So 0 is an x value, 2 is also an x value. Find the y values that go with those. So we'll find f of 0, which will be pretty easy. Zeros are always nice and easy to deal with. F of 0, the 4x cubed will become 4 times 0 cubed. The 6x squared will become 6 times 0 squared. The minus 24x will become minus 24 times 0. And I have plus 11. So the stuff with a 0 in it just stays 0, and I'm just left with 11. So far I have negative 3 and 11. I also have to find a height for my endpoint of 2. So f of 2 equals 4 times x cubed becomes 4 times 2 cubed. 6 times x squared becomes 6 times 2 squared. Minus 24x becomes minus 24 times 2. And then plus 11. So if I do the math, 4 times 2 cubed, do the 2 cubed first. 2 times 2 times 2 is 8, positive 8. Times the positive 4 in front. 8 times 4 is 32. It's positive. And then 6 times 2 squared. 2 squared, 2 times 2 is 4. Times the 6 in front. 4 times 6 is 24. Also positive. Then I have minus 24 times positive 2 will be minus 48. And then plus 11. So if I combine my positives, 32 and 24 will be 56, and 11 more will be 67. Minus 48, 67 minus 48 would be 19, positive 19. So the last step is state your absolute maximum, absolute minimum. The absolute maximum, your choice are minus 3, positive 11, or positive 19. Well, 19 is the biggest. So the absolute maximum for this problem is positive 19. And the absolute minimum, your choices are negative 3, positive 11, positive 19. Well, the negative 3 is the smallest. So by changing the interval on the previous question, I changed the answer. Now the absolute maximum is 19, and the absolute minimum is negative 3.